Hello and welcome. Today, we're going to talk about super materials that will leave you amazed. Metamaterials. Ready? Let's dive in. Metamaterials are materials created in the lab by scientists that do not exist in nature. These materials interact with light and sound waves in extraordinary ways. So, how do these metamaterials work? First, there's something called negative refraction index. Normally, light bends when it passes through a glass of water, making a straw look broken. But in a material with a negative refraction index, light bends the opposite way. This property is like having the straw appear straight instead of broken when dipped in water. This allows us to bend light in extraordinary ways. Another interesting concept is the reverse Doppler effect. Normally, as an ambulance approaches, the sound pitch gets higher, but the reverse Doppler effect makes the sound pitch lower as the ambulance approaches. Metamaterials can create many innovative applications by directing light and sound waves using these extraordinary properties. Resonance is when these materials absorb maximum energy at a certain frequency. Think of swinging on a swing set. At a certain rhythm, you get the highest swing. Metamaterials perform best at certain frequencies in a similar way. Now let's look at some applications of these super materials. First up, invisibility cloaks. Yes, just like in Harry Potter. Now let's look at some applications of these super materials. First up, invisibility cloaks. Yes, just like in Harry Potter. Another application is super lenses. Normally, we use microscopes to see small things, but super lenses allow us to see details at the atomic level. This is like using a magnifying glass to explore the microscopic world, but much more detailed. You can see everything at the nanoscale. In telecommunications, metamaterials can create steerable antennas. These antennas can direct signals to specific directions, reducing interference. This is like pointing a garden hose to control the flow of water. It makes signals stronger and cleaner. Metamaterials can also direct sound waves. This property is great for sound insulation and acoustic control. For example, you could have special coatings on your walls to block outside noise. Your home would be quieter and more peaceful. In the future, metamaterials working in the terahertz range have great potential in biomedical imaging and security scanning systems. Terahertz waves are like X-rays, but safer and provide more detailed images. This could revolutionize the biomedical field. Active metamaterials can change their electromagnetic properties in response to external stimuli. This means the materials can be adaptive and dynamic. Imagine clothes that change color based on the light conditions. This could open new doors in fashion and technology. Metamaterials offer great opportunities in engineering and science. It's an exciting area for innovative applications and discoveries. These materials can manipulate light and sound waves, making them useful in many different applications and becoming more widespread in the future. In summary, metamaterials will revolutionize the world of science and technology with their extraordinary properties. Stay tuned to learn more about these super materials. Today, we learned about metamaterials and took an exciting journey into the technologies of the future. These super materials will continue to revolutionize the world of science.